Hey, what's up everybody? I am just going to paste the link here to the live stream if I can find it. Let's see here. There it is. I should be able to do that. Crazy, I'm looking at myself. Okay. Live stream project. Let's do it. All right, hey everyone. So today I am going to be working on composition 6. I'm going to be showing you some strategies, some tips, and some tricks as to how to engage in the data analysis portion of the project. One thing I wanted to show you was this data. If you recall, my live stream project is ultimately about partisan responses to the public health crises in general. In the case, obviously, some of the data that we want to work with is the sort of COVID-19 reaction. And so in my earlier part of the study, I had written sort of an introduction that describes some of the things that are happening right now, and then describes the partisan identities having a potential impact on responses or sort of public concern. And so I posed this question: among Americans, does co-partisanship with the incumbent presidential administration affect level of concern over public health crises? So that's kind of where I'm at right now in terms of my sort of idea here. And so I had not written the lit review. I'm going to go ahead and wait on that one until composition 7, just because that's not something that is super useful for you at this moment. But if you recall, I had written a theory that kind of showed you some of the why statement stuff, why I would expect in this case this direction, right, where the incumbent, the co-partisans of the incumbent will exhibit not no greater or lesser, but right, my main hypothesis, co-partisans of the incumbent president will exhibit a decrease in concern over public health crises relative to members of the out party, all else equal. And so in preparation for this live stream, I had gone back to my Twitter feed and I had found this tweet from Pew. And so there's this really great survey out there called the Election News Pathways Survey of March 2020. So, so the issue here, let me reset my password here. Probably don't want to do this online while I'm live streaming, but the issue is that I could not find my password for the Pew data to be able to download this. I don't think it's right. Yeah, so I'm not able to download this right now. Maybe I'll come back in the next day or two and do the survey-based analysis. But since many of you are not working with survey data, since you're working with sort of other kinds of data where you're producing a data set like this with maybe states or something, I thought it might also be prudent to just very quickly kind of show you my composition 5 basically in real time. Recap this by putting in essentially the state scores on a sort of state level indicator potentially of this level of concern. And so one sort of very basic level of concern kind of thing that I sort of cribbed from the Brian Schaffner thing that sort of led me to do this study in the first place was sort of Google Trends searches over the last 30, or I guess 90 days. I could do 30 days if I wanted to. It's essentially the same trend, just compressed here. Interest over time, specifically by sub-region in medical gloves. So medical gloves, obviously being, if you put the medical gloves on, it suggests that you're probably more concerned about the COVID-19 crisis than otherwise. I would love to be able to truncate this series to be able to get a specific, here we go, custom time range. That might even be better, right? Because if you recall, one of my intervening variables, actually I'm going to do this twice. This will be really cool. I'm going to get rid of this thing. I don't need this anymore. what I'd like to do is I'd like to figure out sort of when does the Trump administration start becoming serious about the crisis, right? So if I recall, well, so here's a great paper here. Trump signals new guidelines. Okay, so this is March 23rd. Obviously, this is a little bit late, right? But so Trump administration rolled out a 15-day plan on March 16th to bend the curve. Okay, so maybe March 16th is a good place to cut this because that's a really like visible date for this announcement. Maybe that's one way we could do this. Anyway, basically, I'm trying to grab my dependent variable here, this concern at the state level. And so what I'm going to do actually is I'm going to get from February 16th, or this is kind of before this announcement. It's actually great because it's exactly a month, right? 2/16 to 3/16. So let's look at that. Okay. So here's, you can see that the interest is increasing in March, right? But we can see that there are certain places where the interest is higher and other places where the interest is lower. And so what I'm going to do here is I'm going to download this data. So we've got 1 through 5 of 49 subregions. Ooh, are we missing? I guess North Dakota had no data for this one. That's okay. We'll lose a case here. But I'll go ahead and download this, and I will have this state ranking, basically. Missing Alaska and North Dakota, it looks like. But I basically have state rankings for concern. And this is, of course, prior. Oh, I think we have Washington, D.C. in here, don't we? Yeah, I think we do. District of Columbia, here it is. I'm going to remove that. So now we've got our 50 states. You see that they're out of order. We'll be fixing that in just a moment. So this is kind of the, I'm going to call this concern pre. We'll use camel case here to be consistent with my instructions. And then we're going to get eventually a concern post, which will be kind of fun to see. So we'll get rid of this. Now we'll get concern post. So now we want to filter this. I'm just going to filter this to be another custom time range. Let's say, I guess technically I could do the past month because it's exactly that month. 3/16 to 4/16. So now let's see what this pattern looks like. We can see that it differs, right? So DC is the top, New Jersey 96, etc. We've got all 51 subregions in this case this time. Could it be that no one from those states searched for gloves in the time period? Absolutely. It is very possible that it's 0 there. And in fact, if I were savvy, I might put in essentially to say it's essentially 0%. I could do that. That makes sense. I'd have to read carefully, right? I'm doing this in real time and doing this quickly. I'd have to read carefully how Google does this, right? Go into their documentation. I'll do that for now, just so we have complete cases, because it's a little bit better. I have to doubt that across an entire state, right, that 0 people searched for it, but it may be that it's too small. Essentially, the search interest was negligible or sort of marginal, and so it ends up being 0. Because you can see here, still it's pretty low. Of course, this is scaled to population, right? So this is not to say like, oh, New Jersey searched for this a lot because a lot of people live in New Jersey. That's not really the case. It's scaled to the population of the states. But so let me see. Did I get this yet? No. I'm going to download this again. We'll see. I've got my second geo map. It's kind of fun, right? Second geo map. We'll get rid of DC again because we're wanting to look at states. Unfortunately, sorry, DC. I'll peel this down. Oh, we've got a couple of extra. Oh no, that's because the list is shifted. Okay, so now we go down here and we've got concern posts. This is essentially post this kind of arbitrary. Again, I'd want to be a lot more careful, right? If I were doing this, if I were actually making this my real project, I want to make absolutely sure that that date of the 16th was the appropriate sort of cut date for this. So we've got state ID. Okay, so what I'm going to do here is I'm going to go ahead. These are all the same, basically. I've got my state and state ID. I'm going to take these two columns and I'm going to sort. I'm going to do a custom sort here, and I'm going to sort by column A here, which is state. Oh, my data has headers, by the way. So it's state and A to Z, just to make sure that we're in exactly a alphabetical world. Now I'm going to go ahead and take this one as well. I'm going to go ahead and do that same sort and filter command. Custom sort, I'm going to say sort by column this guy's column C, and again A to Z on cell values. So we'll see now all of a sudden these get tied together, but now they're starting to look the same. So we've sorted this so it's now back in order. This is just a little trick, so I don't have to go in and like move these one by one. Sort and filter this one with a custom sort on column E. We'll do A to Z as well. Okay, so now I can delete these little state modifiers that came with it. Now we've got our concern pre, our concern post. One interesting thing I could look at is like the difference. That might be a really cool concern diff. Could be kind of interesting, right? Maybe just another thing to have in the analysis. I might actually make that in RStudio just to show you how to recode a variable. But so there's, of course, other things. First of all, these are kind of the two dependent variables I want to look at in the study. But there's some other things that we probably want to know, right? One thing might be sort of how conservative or liberal is a state, or kind of how blue is a state. That would be pretty useful. And so one thing that I'm going to do here is go into my online modules here. Let's see, we can look at my, let's see, measurement, where is it? Indicators. Somewhere in here, here we go, data source possibilities. So you recall from the data source possibilities that one potential one, if you're looking at the states, would be the Cook Partisan Voter Index. You can open that up. We'll see this Cook Political Report. If we visit this page, we'll be able to get this data, Partisan Voter Index by state. I just want state. This is going to do it by district, isn't it? We don't want that. I haven't used the Cook Partisan Voter Index PVI map, I guess. Well, this could take a second. Hopefully I'll be able to get a statewide. I guess one thing I could do is just find, how about this, statewide Trump vote share. That seems like a pretty good way to do this. Go to the Wikipedia page as usual, right? Results. Find state by state results would be really helpful. Okay, here we go. So this is a tabular data that shows this. Thankfully, it's in this nice, again, arranged by state alphabetical, so that's cool. Maybe Excel will handle this if we try to dump this into another Excel file. Let's see if we can do it. It might blow up. Oh no, it worked. Okay. So we've got our states here. They're all nicely. Oh, one thing we've got to figure out is we've got Nebraska. A couple of these states might be a little wonky here because they separate these into congressional districts. So we might just want to take the at-large or something. But so at least for most of these, we know that, let's see, going back, Trump's share is kind of that second percentage here. Let's see, this one right here makes sense. So I'm going to go down here. We're going to get rid of DC. Let me find my other data. Where did my data set go? Here we go. Trump share. Oh. Here we go. Ugh, these have percentages, don't they? I'm going to have to get rid of that. We'll deal with that in due course. So we got Florida, Georgia, Hawaii, etc., Indiana, Louisiana. We'll get the Maine at large as well. So many tabs. Here we go. Maine is there. Now we can move down to Maryland. Maine, Maryland, Massachusetts, Michigan, Minnesota, Missouri, Montana, Nebraska at large. See, having things in alphabetical order is really helpful. Now Nevada, Hampshire, New Jersey, New Mexico, New York. All right, look at that. We got all of them. So that should be, yes, a complete set of cases. All right, now one thing we want to do is take this and remove the percentages because that's going to hurt us later. General, okay, there we go. So there's the Trump share variable. That's going to be our IV. We want to see if Trump share has an influence on whether people are concerned pre and or post. Maybe we'll look at the difference as a potential dependent variable. And then maybe there's something else that we want to know about these states. I don't know. Let's see, we could consider the idea, this is like very off the cuff, right? We consider the idea that maybe like states that are relatively well-to-do, maybe those states, people are sort of ahead of the curve, so to speak, on this because they, I don't know, like they are able to parse information better or something. It's a very like weak like alternative theory, but I can't think of anything off the top of my head. If you want to get in the chat and give me some suggestions for other like third variables to include, but I'm just going to throw in state GDP per capita as a possibility. So we've got, again, very nicely, we've got this little table that we can like paste into Excel from Wikipedia. Oh, here we go, current. It's maybe even easier. We can get rid of DC again. Sorry, DC, you probably should be a state, even though you're not. Throw that in there. That should, again, tabularize very nicely. You can get rid of DC. Oh, this is very annoying, these little things. I'm hoping that these little flags don't hurt our ability to sort this data. Let's see what happens. Custom sort by column C. A to Z. Okay, no, it didn't hurt it. So again, these are all, oh, we've got US in here. We don't want that. These are all now in alphabetical order, so we can just take the GDP per capita, which is essentially a measure of basically like how productive each state is scaled to the individual. So usually that's pretty correlated with like how people are doing financially. Let's see. So go back to my thing. We can say GDP. I'm going to say GDP PC. One thing that's really important here, you'll see that I'm using camel case for all of my state identifier information, state ID, concern pre. These are all ways that it's going to be easy. Oh, what have I done? I've lost my data because I got so excited about naming conventions. But okay, so here we've got our other variable. GDP PC, I'm using these capitalized letters here to indicate like abbreviated next words so that it's more interpretable. Concern pre, concern post. But notice I'm not putting spaces in these, right? These become the variable names in R, so we do not want to do that. Okay, here we go. I'm going to take this data. I've finished 5, right? How incredible. I've already finished my data for composition 5. It only took me 19 minutes. Pretty good timing. Let's see here, spring 2020. We put this in the live stream project. And what am I going to call it? Why, it's an Excel workbook. I want to name it DAT. I always want to name this thing DAT. So I'm going to save it. It is now called DAT. And I'm ready to bring this into R. Okay, so again, going from my composition 4 and my hypothesis to the collection of data and the availability of data. Of course, when I'm writing in the next section, which will be a part of composition 7, the final composition, my method section, I'm going to be writing about sort of where I got the data. I'm going to put these in bullet points for now, just so that I can be clear. Where I got the data, what I did with, let's see, what I did with it. I guess before that, introducing the variables and their levels. Okay, so basically I want to be able to have in this method section as much information in as you had in composition 5, where you talked through what this data is, where it comes from, and then like what it looks like. And so that is going to be something I will write in a little while in the method section of what will eventually become my composition 7. But first I want to do the stuff that's involved in composition 6, right? Composition 6 is pretty much like very little writing. It's interpreting some of this stuff. It's writing through like what your impressions are, kind of like quiz 9, what your impressions are of the data. But for now I just want to do this in RStudio just to show you kind of what I'm talking about in terms of the actual analysis. So I'm going to import my DAT from Excel, be able to bring this in. It should be under my live stream project. Here we go. I've got my DAT. And I should, hopefully, again, I've never used this data before. I'm going to have to check it a little bit. I should have no problems with this. I'm going to import it. There we are. We got 50 observations of 6 variables so far. got my DAT, and I'll be able to begin kind of analyze, like let's check it out, right? So one thing that I can do is I'll take a look at the key variables. So let's look at DAT concern pre. This table is going to be kind of huge, but you can see it ranges from 0 to 100. That's really cool. It's like a really helpful thing. One thing that we want to make sure of is that our dependent variable has variation. The Forest Yearbook, let's see, it's on top of my case here, my computer case. The Forest Yearbook has like very helpful information about this in some of its chapters, especially this sort of multivariate regression chapter, talking about the need for variation in your variables. And so if like 99% of this data was like between 90 and 100, it wouldn't be very meaningful. But the idea that there's this massive variation, a huge spread in terms of concern, from like 0% or whatever this metric is, 0 units of concern to 100 units of concern, that's very helpful. Interestingly, if we look at concern post, the sort of other DV that I want to look at, we'll see that also like this like level of concern seems to vary as well, which is quite interesting. I thought it might be kind of fun, a concern diff variable, which is pre or is post minus pre concern. So essentially, positive values are equal, or essentially concern grew. Negative values, concern diminished. So the idea is, did concern grow in some places after the sort of Trump announcement, which again the 16th of March is kind of the timeline that we're looking at, the point at which it seems like the Trump administration started to signal a lot more about this. And so the way we can do this is we can create a new variable. I'm going to call it concern diff. And of course, if we're creating this thing doesn't exist yet. If I were to call it in my data interpreter, if I were like, hey, show me this data, what does this look like? What is it going to say? It's going to say null, and it'll say unknown or uninitialized column. So if you're working with your variables and your data and you get an error like this, what it means is that probably you've misspelled something. Like if I were going to try to say, oh, show me concern pre, and I called it concern perv or concern pru, it would give me the same error. I don't know what that is, right? If I did it this way, we'd see that we get all the values from 1 to 50. But so of course I want to make this new variable called concern diff, and it's equal to, well, we can do some simple math the same way that we did simple math in previous times. Dat concern post minus dat concern pre. So if we create this variable, I'll just highlight it and I'll just run this. You'll see over here, maybe you can't see because of my face is in the way. Maybe I can move this just very briefly so you can see it. You can see I got 50 observations of 6 variables down here. Hopefully that's far enough away from my face where you can see it. When I create this new variable, we'll see that it grows to 7 variables. So we add a new column. So we'll hit run, and we'll see now, again, maybe you can see this, maybe not, 50 observations of 7, which is good to see. Okay. So now I've got this new variable. I can start looking at that one. Table dat concern diff. This one, interesting, is really interesting actually. Some of these states have like massive decreases in their level of searches for gloves, presumably because maybe they already got them. And then other places are starting to sort of get really into it, right? And so that I think could be a very interesting variable to look at. But of course, I also want to look at some of my other variables too. Trump share, that could be interesting. You can see it ranges from about 30% to about 68%. I'm trying to think what these 30% states are. Not sure exactly which one Maryland was, but it's pretty low down there. This one, I want to say it's Utah or Oklahoma. You'd have to take a look. But anyway, this is, of course, the data. We can look at the GDP per capita variable as well. You know, I'm going to actually transform these variables using a similar kind of thing just to make these prettier. You could do this in Excel or you could do this otherwise. It's not really difficult. I'm going to recode my Trump share variable to to actually be in a percentage that ranges from 1 to 100, or from 0 to 100. So you'll see that this suddenly becomes 100 times bigger. So now it's like, instead of 0.030, it's 30.03, right? So I just made it 100 times bigger. Then I'm going to change that GDP per capita to be that variable. What's happening? So bad at clicking. Divided by, let's divide it by 1,000 so that it's like in thousands of dollars, because that is, of course, the scale. So if I do that, right, now we've got 37.9, basically $37.948,000 is the lowest here. $85.7,000 is the highest. So that'll become helpful in the regression and other kinds of visualization things as well, because giant numbers and tiny numbers usually they make interpretation kind of hard. So even in quiz 9, if you recall, there was like a really small coefficient, like negative 0.032 for the effective horsepower, and that's because horsepower like ranges in the hundreds. And so if I had done it by hundreds of horsepower, it makes interpretation a little bit wordier, but the coefficients are easier to look at. So anyway, I've kind of looked at these things. I can do the STR. I'm pretty confident in this data because I just made it and I just looked at it. But if we look at like concern pre, like that's numeric, right? Look at Trump share, that should also be numeric. So we're in good standing. We don't have any characters floating around creepily in our data set. So checks complete, looks good. Transforms were successful. One thing I could do if I wanted to, I know these are complete cases because I just built the data, but I could also do this one, get rid of any missing values. And so if I ran this and I omit, nothing happens because I didn't have any missings. But if you have missings, that's a really important check. So got rid of any and all missings. Okay, next. What's the next thing we want to do? Bivariate analysis. So of course my main variable relationship is going to be, what's my independent variable, right? It's continuous. So this is going to be continuous versus continuous relationship. And so one quick way to do this, one way that would be very easy for you to do this, would be to go over to your bivariate relationships tutorial R file that I showed you here. Make sure that these are installed here. So I've got to make sure my tidyverse is in there. There it goes. And now I'm going to grab the appropriate continuous tools for bivariate relationships. So I'm going to grab the core test, and I'm going to grab the scatter plot. And so I'll go back to my other do file, and I will throw this in here. So the first one is I want a scatter plot. And in fact, maybe I'll open up, let me open up the module from number 6. This case, I'm going to do this just to show you, because it's such a cool plot. I love a plot like this. I'm actually going to use a plot that uses ggRepel. I'll load that up. I'll do a scatter plot that's got ggRepel in it, just to show you how cool this plot is. I love it. Labeled plot. So we've got the qplot command again. Our data is not tabless anymore. We got to get rid of that. Data becomes dat. We don't have ABV in this, right? What's our independent variable? That's always the x is the independent variable. And so that is going to be, what did I call these? Can't remember. Let's look at concern post in the first, or concern pre. Let's look at concern pre to start. So that's going to be Trump share becomes the independent variable. So we've got sort of readiness of states as a factor of sort of Trump share. And then we've got this concern. Yeah, let's look at concern pre first. And then the label here, this is the thing, this is why I've saved this column state ID, because they're like short. I want to do state ID here. This could be really cool. The geom is going to be points. This is one thing I wanted to make sure that you guys pay attention to. Watch out for these quotation marks. If you get rid of one, you'll see that it starts to really mess up our do file, and you'll see that this will break. So don't let them like disappear, don't delete them, don't put 2 on one side. That's also going to screw things up. Make sure that anytime I've given you a block of code that's got quotes in them, that you make absolutely sure that the quotes are preserved when you do this. So we want the geom to remain the same. It's just a scatter plot. Of course, we're not dealing with beer data anymore, so I'll make sure that the X label is share of Trump vote, or share of vote for Trump 2016 election. We don't want our label to get too long or else it'll start to wrap and be really ugly. I could say a lot more about what that means, but I'll just leave it as this sort of not very detailed label. Y label is not price, it is, what was it, right? Level of Google Trends interest in medical gloves. And of course this was when? March, February 2020. And then the main, we can call this a scatter plot. Interest in medical gloves versus Trump vote share. I'll capitalize these for the interest of prettiness. Okay, so we should be able to grab this, and if my calculations are correct, we should be able to run it and it will make a pretty graph. I'll blow up this graph window so we can see it better. Run that. My goodness, how interesting. What an interesting cloud. This is really, really, really interesting to me. Because what this shows me is, I mean, again, let's look at this together. Let's look at this graph. Do we see a trend here? Is there a trend? I don't know. Get in the chat maybe and tell me what you see. I'm really interested in this. It's a pretty fascinating graphic here. I think there's a little bit of a trend line here. I mean, you look at some of these states that are pretty blue, all things considered. I mean, Hawaii and Vermont are essentially the least likely to vote for Trump across time, right? And then over here we've got some states in the middle that are, again, sort of in the middle of this here. And then down here we've got a few of these, like North Dakota is really pulling this. I mean, we've coded this as 0, might be an assumption. But like even without it, Arkansas, Oklahoma, some of these, like the sort of cluster of states down here is like, look at these 4 sort of little gray squares. Compare those to like these 4 little gray squares. There's about as many states here. Yeah, I think you're absolutely correct. Right? This looks like a somewhat flat, right, negative relationship. Now, one thing I'll tell you though is that the scaling here and the dimensions of this plot also can change our interpretation of the sort of depth of this negative relationship. I'll show you if I pull this a little bit, I can make it look a lot steeper, right? We'll see. We'll wait for this to upload. Yeah. So again, we've got a few states over here that are like kind of outlier cases, off diagonal cases, but like the diagonal snaps into focus a little bit when this is more squished. If I try to make it as square as possible, so I make it square for fairness, right? Yeah, this negative slope is still there. It's just we're sort of, moving the graph around to make it look steeper or flatter. So what we really want to do is probably calculate some kind of correlation coefficient to make sure that we're really sure that this is happening. When we get into the regression context, if we do a regression between these 2 variables, the slope of the potential line that we might draw between this cloud of points, that's actually the coefficient of the regression. So that rise over run, right, that slope of that line in real absolute terms is actually the regression coefficient as well. So that's one of the other powerful ways that regression coefficients are useful, is that they allow us to make interpretations without just staring at the data. Yeah, we could actually. So the question was, can we overlay this line if we wanted to? So yeah, if we use this, we'd be able to add the same way that I've added this geom text repel. You'd be able to add an AB line once we were to calculate the line from the regression, and then just lay that over. So let's figure out what the slope and intercept of the line would be when we get to regression. Maybe we'll go back to the graphic and we'll add that on. But yeah, I mean, I can generally tell you it's going to look more or less, if you can see my cursor, more or less the way I'm drawing it, right? probably the intercept somewhere around 76, and then declining probably to about 45 or something. So it's a pretty steep, actually, altogether kind of slope, right? Across from like 30 to 70 in terms of the Trump vote share. One thing you'll notice is that this is automatically sort of cut out parts of the graph for which there were no observations. So theoretically, right, the share of vote for Donald Trump could range from 0 to 100, but we don't have some of those regions of the graph because they're not useful for our purposes, because there's no state that voted 0% for Trump. Okay, so let's look at the correlation. This is going to be the first indication, because the core test will give us a p-value, right, as to whether or not this is like a meaningful trend. So of course we want to get rid of these things. We don't have to tap list anything. We've got dat concern pre, and we've got dat Trump share, right? So I'll put those two things in there. I can run this puppy, and we'll see, interestingly, that the p-value is 0.007. P-value is less than 0.01. That's really great. I'm going to put a note in here. That is, first of all, really good news for the perspective of my study. Because what this is telling me is that with this, even with just 50 cases, this sort of relationship is strong enough. And again, I'm not messing with you here. I pulled this right off of Google Trends, like literally 17 minutes ago, right? You saw me do this. I'm not making this up. This is kind of crazy. I'm a little bit amazed to see how strong and significant this relationship is. It's pretty wild, actually. P is equal to less than 0.01, which, again, if we were to interpret this p-value in like very broad, sort of, so like some frequentist statisticians might be mad at me by interpreting it this way, but for our purposes, we could say essentially that we have there's a very low possibility that this relationship was due to random chance alone. So like, we can think about what random chance means in this case. What it means is that like, it just so happened that like, you know, Karen, age 44 in New Mexico, like Googled hand sanitizer like 990,000 times by accident because her computer's like enter key got stuck to a piece of gum or something, you know, and like it like artificially inflated the statistics here. And then just randomly through some random chance, right? Somebody over here in Alaska who's like a medical glove like buyer extraordinaire, and somebody who loves medical gloves and who like is an aficionado and Googles medical gloves every day, like happens to like get their legs stuck in a bear trap or something when they were out in Alaska catching salmon or something, and wasn't able to get to the computer for that month and couldn't type in medical gloves 100,000 times. And so like these two random sources of variation like were part of the reason that the pattern existed, plus a whole bunch of other potential sources of random variation. That would be like the potential random threat to validity. There could be like the universe could align in weird ways to cause this pattern randomly. And so the pattern we're observing actually isn't the true product of the relationship that we're trying to say here. But what the p-value is telling us is it's like, man, this relationship is so strong that like, what are the odds, right? What are the odds of all this random stuff conspiring to cause this pattern otherwise? And so it's saying we're essentially rejecting this assumption that it was randomly determined. So of course this comes with a t-value of -3-ish, right? And we can see also that it'll give you this really cool thing, a 95% confidence interval, which is to say that as long as this confidence interval doesn't include 0, it means, look, we're like 95% of the time, if we were to do this over and over in a bunch of like fictional worlds, we would still get a negative correlation. So we're really sure about the direction of this relationship. Our best guess as to the strength of that relationship is -0.37, which again, in the sort of world of the social sciences, is a pretty strong correlation. Like this is again, like I'm surprised. This is surprising correlation. And we can say R equals 0.3373. So if I were to do my bivariate analysis, I'd be able to go in, I could show this scatter plot, I could say, look, the correlation coefficient is -0.37, it's significant at a level of 0.01. Like, wow, this is a really meaningful relationship. And so I'm like flabbergasted at this. Another one I could do, let's see, what's the other one? Oh, the GDP, right? This is also going to be, I should have picked maybe like a categorical variable for you just to show you like a box plot or something. But you did see that in quiz 8. So I'll do another one here, where let's look at GDP per capita, because this is, again, like, we'll see if this is true or not, but there's a possibility that there's a spuriousness problem here, where like it just so happens that wealthy states are really savvy or something, or that they were warned by their, you know, very high-income primary care physician or something to put on medical gloves. I don't know. Maybe it's that wealthy states have a lot of money that you know, medical suppliers could have bought these things before poorer states or something. This is all spitballing. That would be a terrible theory that I would probably raise a lot of questions about if you were to write that in your assignment. So anyway, I can just, for the purposes of illustration, throw in GDP per capita in here. So this, in this case, it's actually control variable 1 instead of this, GDP per capita, concern pre, state ID, change the label. This becomes GDP per capita, scatter plots, interest in medical gloves versus GDP. I'll just say state, just so we're not confused, because GDP per capita is also measured like across time. So we can run this. We'll see how this changes. Yeah, this is interesting. There is a positive relationship here. Although these North Dakota and Alaska, these are pretty low outliers here, right? This might be not as strong of a relationship as the previous one. And I'm kind of interested in maybe your all's interpretation of this trend as well, right? Like, what do you see here? I'll try to make this square again in the interest of fairness to the trend. I see a less definitive cloud of points here, especially if we look at like states like New Mexico, relatively low GDP per capita being the highest in the trend here. States, again, these low outliers here pulling the curve. This could be probably not as strong of a relationship. But of course we can find out for certain whether or not that's the case by doing our correlation, right? So instead of Trump share, we can put GDP-PC. Highlight that whole thing, remembering that bottom parens. I put that in there just so that you don't accidentally delete it. It doesn't matter, it can go on this line too, but I put it down here just so that we're sure not to mess with it. We can run that and we'll see, yeah, look at that. P-value 0.44, that's a big p-value. That means that it's quite likely that this cloud was the product of random chance. And we are unable to reject the null hypothesis that the correlation isn't nothing, right? I know that's kind of a double negative, right, kind of statement, but we can reject the null hypothesis, basically, that that this is, or we can't, sorry, we fail to reject, right? We cannot, again, like the idea of accepting the alternative, that's not really the way that statisticians talk about this, because we don't ever accept the alternative. It's more that we reject or fail to reject the null. So we fail, in this case, to reject the null hypothesis that this correlation is 0. And so if you look at a great way to illustrate this is the 95% confidence interval. We can see that among the values where we're 95% certain, sort of where the true value is in reality, it could be anywhere between negative 0.17 and 0.37, almost 0.38. So again, like if we were to do this over and over again 100 times in like a, in a set of alternative worlds where like these are slightly different, again, like a lot of the time we're going to get something that's either negative or positive and we can't tell. And even the correlation value here is 0.11, which is a really, really weak correlation. And again, in other trials, it might end up just being 0. So really, there's not much of a relationship, we can say. And just for the purposes of just because I'm interested, for the purposes of nothing, based on except for my pure interest, I'm going to run post. Let's see if we can do post. I'm interested in this. Let's see if this is the same size correlation. Wow. It's if anything even stronger. Let's see if it is. So this is actually maybe messing with some of my theory. All right, this is 0.59. This is even stronger. In this period from March to April, we're actually seeing that the sort of so-called blue states are actually getting more interested in this. Now, if I were to think carefully about my theory, right? My theory was about the president signaling something, and then the president saying, okay, these like red states are suddenly starting to like get the message that this is really serious because they follow the leader, right? There's a potential intervening variable here, right, that might be influencing this. And that is, if we look at some of these states, California, New York, New Jersey, where interest in medical gloves is the strongest in this post-period, I wonder why that might be, right? Some of these things that are really driving this correlation more than anything else. I wonder why that might be, right? What variable am I missing? Anyone consider a variable that I'm missing? Because this could be a pretty important consideration. And it might be that you don't realize this kind of thing until you get into your analysis like this, until you start to see the relationships. What variable might I be missing? I can think of at least one. Maybe in the chat you can provide a possibility, and in a future live stream I'll go through and I'll find that data and add it. It would be pretty easy to add it actually at the state level. But I think that there's something else going on here as well that we need to consider that has not been considered yet in my regression model. But for now, I'm just going to do a regression using the variables that I have. My one control variable, which it seems based on my whack theory doesn't do much. Of course, we might expect that because it's a whack theory, right? Don't be surprised when your variables don't produce any correlations when there's no theorizing behind them, right? Sometimes we get like a shark thing. Okay, yeah, so somebody in the chat asked about population density as a possibility. Absolutely, that's one that could be a big deal, right? Because people are going to be, regardless of the social distancing kind of orders and stuff, they might be necessarily in closer contact with people, and therefore thinking to themselves, I need some personal protective equipment if I'm going to go out in public, right? I need to get my gloves, I need to get my masks. I really don't want to get this. This is just a horrible disease and no one wants it. And so if I'm forced, right, to like go out in public a lot, I'm going to be searching for it. There's I guess really now that I think about it, there's actually two additional sources of variation that I would want to account for. One is there's another leader that we're following, right? I think this is the one that tipped me off to this possibility, right? Maryland. Maryland in the post period is searching for medical gloves all the time. They're doing a lot of this. And that makes me think about sort of the Hogan administration being like a pretty strong sort of front runner in terms of relative to some of these other states, in terms of like making a really clear and consistent, message to people about this thing. And so it may be that, and of course in California, right, you also had Gavin Newsom making a lot of statements at the time. So it could be that we need to think about governor statements. So that would be something that we'd want to go back and sort of try to gather a little bit more qualitative data on like what kinds of shelter-in-place orders, when did those happen, basically how seriously did governors take this. Like, for example, West Virginia's governor around the same time was saying, like, I think he said go to Shoney's, like, and support local businesses, like, around the same time that Hogan was, like, putting the shelter-in-place order in place. And so some of this statewide variation could actually come from governors and the way that they've handled the crisis as well, beyond just, like, Trump share. And, of course, since gubernatorial partisanship is fairly, but not entirely, correlated with Trump, vote share, right? A lot of these red states have Republican governors. A lot of these blue states, with Maryland being a notable exception, have blue governors. The other one is, of course, how serious, like, how bad has the crisis actually been in those states? So, like, I probably want to know, like, what about the number of cases at that certain time in a certain place? So, like, New York and New Jersey, right, are, like, in real terms experiencing this crisis differently than other places. And so, of course, they might be wanting to, like, find out about how to acquire personal protective equipment if there's, like, like, hospitals are full and, like, there's, like, many people who are suffering from the disease in real time. So, like, those things would probably be important to include, right? Some measure of governor statements / actions, and then, of course, actual measure of crisis severity. That might help to account for some of these, like, high outliers, basically, at the top of the graphic. Anyway, I'll do the regression though with the variables that we do have. Maybe in the next cut we'll go in and try to add some of these other potential spurious variables. Of course, you might be thinking about your own study. You might be thinking like, hey, I don't have time. I'm busy. Like this, I'm in the midst of a international crisis of unimaginable proportions. I don't want to add more variables to my columns. That's okay, right? In composition 7, if I couldn't maybe get this is hard to code, right? If I couldn't get this, I'd maybe write in the conclusions of composition 7, like, hey, this isn't a perfect study. I'm missing some stuff, right? This would be a really important variable to have. I couldn't get it in the time period provided, right? But if I were to do it in the next round, I would go through and do it this way. All right, I would get the newspapers from those states. I would read about when those governors had done X, Y, Z. So that's also something available to you. As you learn more about your analysis and you identify other variables that could be meaningful, you don't always have to do every analysis. You can always save that for the conclusions and say, look, there's some stuff that I missed. Right? Okay, let me find my regression tutorial again. Let me put in some regressions. Let's get our null model so we can interpret a, here we go. So again, as you're building your own do file for your own study, this is basically what you're doing. You're going to do some bivariate analysis. First of all, you probably have already done some of this, but clean your data, make sure it's really clean. Second part of it, you're going to do the graphics and some of these tests, whatever they will be, for the various variables you have. And then you're going to get right into regression. And so the first one I'm going to do is I'm just going to look at data is dat, and of course we're not dealing with price. I'm going to replace this variable name with the dv, which I'm going to use concern pre again, just because it's what we were working with first. You can look at this model, and we will see, similar to our previous video on regression, we've got this estimate, which is the intercept, also known as the constant. It's significant because, again, the significance test here is whether or not the constant is 0. It's kind of an arbitrary thing, but what it's saying is we're really sure that this is not 0. In fact, if we had to give it our best guess is that it's 54.9. And so what this is by itself in the null model is it's just the average. It's basically every time a regression is fitting a model, it's trying to give you its best estimate of a quantity. And so what it's trying to do is come along and say, hey, if you made me guess what a state's level of concern is in terms of this gloves variable, I have nothing to work with. You've given me no predictors. You've given me no information other than the variable itself, so I'm going to guess the average. So the average here is 54.98. So on average, people are Googling masks at a rate of like 54 on whatever Google's like arbitrary scale is. But of course, that's kind of a useless model. What we want to actually do...
Here's some results from the web.
Oh my goodness. That's crazy. My Google phone just listened to me and gave me data on face masks and stuff. Anyway, that's creepy. I should turn that setting off. Thanks, new phone. Okay, so anyway, we've got dat, or data equals dat. And then we've got an independent variable that goes on one side, and the dependent variable remains concern pre. So now we're not using alcohol by volume as our, wow, this is wrong. I should say dv. Here we go, concern pre. And then in this case, we're not using alcohol by volume to predict this. We are using Trump share. So we can run this, grab the summary of the model, and we will be able to see. Aha, look at that. Trump share here with this coefficient, right? And again, a p-value. Right, the p-value being 0.007. Actually, if we go up to our correlation that we ran, let's go back up to that correlation. Oh my gosh, the p-value is the same. That's crazy. In fact, the t-statistic is also the same. That's because in this special case where we just have one variable in here, it's the same essential test. It's the t-test, basically. And it's a t-test of whether or not this estimate is 0 or not. And so basically the math works out the same. But when we're interpreting this coefficient, this is the thing we want to interpret, right? You'll see here, interestingly, the intercept is like 90, which means that this is what happens when Trump's share is 0. Again, that's like a region of the graph that's like there's nothing there. Actually, let me go back and run this first plot again so we can see what it looks like. This is again the pre. Here we go. So if I were to make sure that the graph, the limits here, let's see if that'll do it. Yeah, if we ran this like that, right? See, there's a whole region of the graph that's not used here. You'll see that if we're drawing this line through this data, the y-intercept here essentially becomes that constant in the regression model here. So that fictional line that starts here at 90, and then basically for every increase of 1% vote for Donald Trump, the interest in medical gloves decreases by 0.73 points on this 0 to 100 scale. So we can interpret this by saying, right, we can take this exact same text that I created here, a 1% increase in, not alcohol by volume, in this case it's Trump vote share, is associated with, these aren't dollars, this is now a, what did I have, a negative 0.7, we'll just, right, you can even say about a 3/4 of a point, 0.73 point decrease in, not the price of a beer, in interest in medical gloves from Feb to March. And in fact, one thing we might want to say is this is not at the individual level. We could say among states. Okay. We want to signal to the reader what the population is. And so what does this mean, ultimately? That there is a strong, significant negative association, not between ABV and price. You can see how these start to become very similar, right? Between Trump vote share and interest in personal protective equipment. Now, of course, I could do my next regression, and I could add in, again, let's revise this, dat. We don't have price here. We have concern pre. We have got, what do we have in here? Trump share. And then we've got our one sort of weak control variable, Trump share versus GDP per capita. I'm interested to see what happens here. This could potentially, no. So again, like the relationship stays almost the same. And so even accounting for a potential, and again, a weak, like a crappy potential sort of source of spuriousness, compensating for some of the other characteristics of states, we could say. Trump vote share still has a negative, and in this case, it actually increases slightly in terms of the estimate, still has a negative impact on the interest in personal protective equipment at this time. So that, I think, is very interesting. Let me just throw in one more model, just for the purposes of illustration. I want to see what happens when I model this based on concern diff. This is going to be a very weird model. Maybe I shouldn't do this. Yeah, but look, so yeah, this is something that's very interesting. Concern diff, like this difference like thing that I created, this doesn't seem to have like any, I can do concern post also. I could throw in Trump share GDP, and I could throw in concern pre here to say basically like this is essentially a very similar kind of model. You'll see interest, actually that's kind of interesting. Even accounting for concern pre, right? Like even in this next period, it seems like Trump share continues to have a decreasing effect on interest in medical equipment, all else equal. So like this, again, like these, I'm going to get rid of this model. This is a more confusing model to interpret. We'll stick with this one for now. But regardless, right, if I were to write about this, there are some like important aspects of this model that I want to look at. The first one being, have I done this right? Yeah, the intercept rises to 107, right? That's higher than 100. That's higher than the top of the scale. So again, this is a region for which there's no observations. This is called sort of off the support of the data. So we don't want to interpret this too closely. But Trump share here, again, is negative 0.838. And say again, all else equal, in a comparison of states, a 1% increase in Trump vote share in the 2016, I almost said 2016 election, writing like a teenager from 2002 or something on the internet. Lols. The 2016 election is associated with... Now, one thing we don't want to say is causes, right? No, right? This is observational, right? We can't establish strong causal associations here, even though we have gotten a little closer by compensating for some of the other aspects of states, right? There's still lurking variables out there that we haven't accounted for. Is associated with a 0.84 point decrease in medical gloves. And then of course we put a p-value, right? What's the p-value? Well, it's got 2 stars here, so we can go back to our star chart here and we'll see less than 0.01. So p 0.01. And this checks off all of our boxes here. Checks out. What does it check out? It has strength. Yes. The coefficient. This tells us about the strength because we know about basically every time we increase a percentage increase in Trump vote share, we lose a little bit of interest. Does it have direction? Yes. That's also in the coefficient, but again, we've got this idea that we're putting decrease in here. And then finally, does it have significance? Does this tell us something meaningful about our does this tell us something meaningful about whether this relationship was the product of random chance alone? We're really skeptical that this was just random. It turns out that maybe this is actually something that's actually happening. And then finally, we can also look at the model fit. Let's look at model fit. You see the R squared here is like 0.14, 0.15. Weak, but eh. Remember we said that like in the car data we like fit 85% or something of the variation in fuel efficiency. Yeah, of course, like because it's a machine, right? Like if we're trying to like in an industrial process, like NASA, if NASA's trying to model how their spacecraft operates, they want to make sure that their fits are in tolerances of like 0.9999999, right? Because you don't want to have any error in your model, or else like your spacecraft, like your unmanned probe goes flying off in the wrong direction and like gets captured by aliens or something. In the social world, people aren't machines. People are weird and they do weird stuff, right? Maybe New Mexico is the home of like medical glove enthusiasts and Association of America. There's weaker fit often that we see in the social world. An R squared like this is not great, but it's not horrible. I've often published models with R squareds of like 0.01, right? Because again, it's very, very hard to establish like good variation and model it effectively in the social world. But so the last thing that I could do here is I could also add, right, like substantive interpretation. So I could like look at some of my cases, right? Again, we're looking at this this in Module 6. I can use filter here. This can be kind of a fun way to look at this. Let's interpret the difference here. I'm going to filter dat, and I'm going to look at states for which Trump share is greater than, let's say 65. That's going to be a lot, 60. And concern pre is lower than. So these are states, basically very conservative states that aren't interested in learning about the, let's see. I guess I want to do something like lower than, so let's just do 70 for now. We might get a lot of these. Okay, so we've got 8 cases to work with here. Concern pre being pretty low in states like Alabama, Arkansas, Kentucky. Anyway, what I'm interested in for the substantive interpretation is like concern pre, this thing right here. Let's look at, for example, well, let's take Alabama for now. Okay, so basically, like if I had a state like Alabama, right, and they have a concern pre of 43, their expected concern let's see, what's their Trump share? Alabama 62.1. So we can do a little math here. We can from the coefficients. It's 107.8 minus Trump share 62. 62.1 times the coefficient, negative 0.838. Did I do that right? Oh, because I already subtracted it. That's the problem. So 55.7. So their concern is expected to be about 55. Turns out that's higher than their actual concern, which is interesting. So that's like a margin of error essentially. But if Alabamians suddenly voted for Trump, let's just do 10% less. Or maybe let's do 20% less. Reducing their Trump support to just 42.1%. We would expect them to have a level of concern of roughly, so now we've got, instead of 62.1, we've got 42.1. And so this would be 72.5. An increase of 16.7 points on a scale from 0 to 100. So in this fictional world where Alabama suddenly gets a lot bluer for whatever reason, all of a sudden they're becoming a lot more concerned. And we can see how much, right? It's about 16 points if they were to vote for Trump 20% less. So another way you could do this is to say, like, compare Alabama to a state that is 20% lower, going back to your filter. Right? Trump share is less than 40 and concern pre is greater than 70. A state like California, maybe, or a state like, I guess maybe this is too restrictive. There you go. Let's see. Trump share, yeah, that's about right. Delaware, right? So you could also say more or less, right? If Alabamians became Delaware, right, then we'd expect them to become about 16 points more concerned about this stuff. So my next task in the next live stream is going to be to take all this stuff, right, all this regression output and translate it into something that can be written up in text. One thing I'll do here is I'll just run my stargazer command here. Oh, I don't have it. Don't have it loaded up. There it goes. Could run stargazer on this. This is again from the regression tutorial R script. And you'll see that I get out this really beautiful little table. In another video, I can show you actually how to make this even more beautiful by saving it as an HTML document and then pasting it right into your Word document from the HTML. But for now, we've got this really pretty analysis where we've got the constant here, we're building up the model, and we see the R² increase as we add in coefficients. And ultimately, we can interpret these coefficients and their standard errors, which you don't want to worry about, but basically these two things, right? The coefficient and the stars for every variable. So yeah, it's a lot of fun. Hope that you all enjoyed my little live stream today. If you have any questions about this, please don't hesitate to let me know. If you want to jump on email, or if you want to get me on WebEx at any time, I can always jump on there and we can talk about your own data. So hopefully this again gives you a little bit more of an example to work with about how to get this data going, how to do both bivariate and regression analysis. So yeah, for some of you, if you're working in real time along with me, then you probably are getting really close on your Composition 6. So I'm really looking forward to reading them. I will see you all in just a little while.